Drawing the structures of organic compound from their names. Let us see the examples on the board 1 to 5. Let us draw the structures of the following compound 1, 2, okay, 3, 4 dimethyl pent 1, 2 diene. If you see this kind of name, I always advise you to start from the root, which is what pent. Carbon atoms, how many carbon atoms make up pent? Is 5 carbon atoms. Just start from the root. Start from the root and start drawing. 5 carbon atoms. 1, 2, 3, 4, 5. This is our root hydrocarbon now. Remember, I started from the back, from the root. That's where we start. And if you watch, this thing has 2 double bonds. Carbon number 1 has a double bond. Carbon number 2 has a double bond. That is why they presented this in diene to appreciate the 2 double bonds. Are you getting what I'm saying? I started from the back to draw. And it is, what is the one that is there? It's alkene, E-N-E, alkene. How do I know it's a double bond? It is because of that E-N-E, there is alkene. And I know alkene by the presence of double bond. So, carbon number 1, if you want to number your carbon atom, you are free. You are free. Wait, carbon number 1 has a double bond, and the carbon number 2 has a double bond. I have presented them. Carbon number 1 has a double bond, carbon number 2 has a double bond. Now, carbon number 3 has a methyl group. This is carbon number 3. It has a methyl group. Carbon number 4 has a methyl group also. Is there anything that you are required to do there? I don't think. So you have to fill others with hydrogen, you are done. Fill others with hydrogen, you are done. Don't forget to obey the rule. 4 carbon atoms will surround, 4 bonds will surround each carbon atom. And I think I am done. If you make any attempt to put any hydrogen here, you are violating the rule. Because this carbon atom at the middle has the 4 bonds required of every carbon atom. 1, 2, 3, 4 for this carbon. And for this carbon now, 1, 2, 3, 4. So it's okay. This is the structure of a 3,4 dimethyl pent 1, 2 diene. You can still be checking it while we go to the second one. 2 ethyl, 4 methyl, has 2N. It belongs to the same alkene. And the root carbon here is how many? 6 carbon atoms. Has is 6 carbon atoms. So I'm starting from there. 3, 4, 5, and what? 6. Has 6 carbon atoms. Master those prefixes. It is there in my channel and there on my page. View the video. You can watch the video again. So you can number a carbon atom if you wish. Carbon number 2 has a double bond. I have represented it. Carbon number 2 has an ethyl group. This is carbon number 2. Ethyl group, everybody knows that it is a 2C2H5. Ethyl group. You can still expand it if you are not a professional. You can still expand it. Now, another thing, carbon number 4 has a methyl group. This is carbon number 4. Methyl is CH3. Any other information in there? No. Fill other ones with hydrogen. You are done. Fill others with hydrogen. Okay, this one no hydrogen here. The bond there is complete. This one hydrogen, this one, and this one. That is it. 2 ethyl, 4 methyl has 2N. If you are following me the step by step, the way I'm doing it, you see that it's very simple. Let's go to example number 3. 2, 2 dimethyl, but 1 yarn. The root of the carbon there is how many? But, which is 4 carbon atoms. 1, 2, 3, and 4. And the number of carbon atoms is like it will always help you. It will always help you. Now, carbon number 1 has the functional group. And what is the functional group here? Yeah, is having triple covalent bond. So carbon number one has that three covalent bonds. I have represented it. Now, carbon number two has a methyl group. It will not work. They made a mistake. This is supposed to be 3-3. 3-3 dimethyl with one end. So carbon number three has a methyl group. You say carbon number three has another methyl group. I think we are done. Fill others with hydrogen. That ends it. We are done. Don't make mistake of putting any hydrogen there. Because carbon, this carbon, the four bonds are complete. 1, 2, 3, 4. So if you make any mistake of putting hydrogen here, I'm not the one that taught you that one. Always obey all the rules. That is it. Now, the fourth one, 3-chlorohexane 2O. The important thing, that was why I made video about these functional groups. So anywhere you come across anyone, you see them. And I made video on prefixes. Anyone you see, that is why you see me doing it with ease. Hes, 6 carbon atom. 1, 2, 3, 4, 5, 6. And the functional group present there is what? O. If you can remember, it is CO, which means it is carbon number 2. Let me number the carbon first. 1, 2, 3, 4, 5, and 6. So carbon number 2 carries that functional group 2O. Now, carbon number 3 has a chlorine group 3-chloro. So here now I go to the chlorine group. What is left? Nothing else except filling others with what? Hydrogen. And then you are done. That is it. 3-chlorohexane 2O. And lastly, 2-hydroxyl propanoic acid. Always start from blue to the carbon. That will give you the edge. So propanoic acid is how many carbon atom? 3 carbon atom. If you are following me, 3 carbon atom. And propanoic is like this. And you always start numbering from the functional group. I made a video separately on this arachidonic acid. So this is 1, 2, and 3. So carbon number 2 now have hydroxyl group. What is hydroxyl group? OH. If you can figure that with hydrogen, you are done. If you can remember what I told you last time, ordinarily this OH should be a functional group of alkanol. But I told you that there are some places OH acts as a substituent group and not a functional group. This is the clear example. Here now, the functional group we are looking at here is this oic acid or alkanoic acid. This OH here is mainly acting as a substituent group. That is why you see 2-hydroxyl propanoic acid. This is a clear example of it, where OH is acting not as a functional group, but as a mere substituent group. Take this thing again and solve it in your own way.